I'm on the back of your 3-1 notes, and this whole back page is all about interest at a bank. So it doesn't matter whether your interest is compounded yearly or monthly or daily or continuously. We have a formula to figure out how much, depending on how much you deposit, what your interest rate is, and things like that, how much you're going to have at the end of a certain period, how much money you're going to have. That includes what you originally deposited in the first place. Now, when we look at the ways that interest can be compounded, whether it's annually, quarterly, whatever, for those of you that have watched the movie Harry Potter, I can't spout off the names of the which movies this was in, but there was a very famous bank in some of the Harry Potter movies. It was called Gringotts. And if you remember, if you've watched the movies, Gringotts was run by goblins. So these little ugly creatures and kind of bad attitude, they're the guys that run the bank. And to get Harry Potter to his vault where all of his money is kept, they take like a roller coaster ride to get to the vault. So this is kind of the way that I like to think of banking. If your interest is compounded annually, what that means is if you had an account at Gringotts, one of those goblins would go to your vault one time a year and deposit your interest into your vault, walk away, and wait another year before doing it again. That's what compounded annually means. You get interest deposited one time a year. Quarterly means 4 times a year. So the goblin would go to your vault in January, April, July, and October, I guess, and deposit interest in your account. Not as much each time as this one, but turns out it's going to be better for you in the end. Okay? And then monthly, he would go once a month. Daily, he would go every day. Deposit a small amount, but it would all add up more than likely to be better than once a year. Okay? Or continuously, this is kind of a cool concept to think of. You would get a goblin assigned to your vault, standing there 24/7, constantly throwing coins, small, but constantly throwing coins into your account. You get continuous interest. He would throw a coin in, reevaluate how much is in there, refigure your interest, and throw more interest in accordingly. See how much is in there, recalculate, throw in accordingly. See how much is in there, recalculate, throw in accordingly. Okay? That's what continuously means. And it doesn't always make a huge difference, but usually this would earn you more interest than compounded annually. Okay, so let's take a look at these formulas. The annually, quarterly, monthly, daily, we have a formula for that. This is your formula. You've seen it before. You do not have to memorize it. So let me go through what these stand for. This is going to be your ending amount. So when it's all said and done, after how many years, this is how much you're going to have in your bank. This is the amount you start with. So when you walk into the bank and you say, hey, I've got money that I want to deposit into a checking account or a savings account, this is how much you start with. Big parentheses, 1 plus. This number is your interest rate. It has to be input into your equation as a decimal, not a percent. So you have to change your percent to a decimal by moving it over 2 spaces. All right, so that's your interest rate. This is the number of times a year that it's compounded. So if it says it's compounded annually, this is going to be a 1. If it says it's compounded monthly, this is going to be a 12. So, and this is the same number. Denominator and up in your exponent, and then t is the number of times per year that T is the number of years. How long is this going to go on? Okay, so let's do a problem involving that formula. So I've kind of color-coded it. First of all, it says it's compounded monthly, so I know I'm going to use this equation. Our initial investment is $50. Okay, I colored that red, and that's our P value. 4.8% is our interest rate, and I changed that to a decimal. I moved it over 2 places. So that's R. It says it's compounded monthly. That means N is 12. And we're going to do this for a total of 3 years. T is 3. So look where I put everything. Initial amount, rate, monthly, 3 years. You can type that into your calculator. The only thing you have to be careful of, especially on scientific, make sure that the 12 and the 3 are both up in your exponent area, okay? And then you should get $57.73. You might want to pause the video and practice that to make sure you can do all that on a scientific calculator. Next question. Let's do the same amount, same rate, same time, but let's compound it continuously. So some guy is sitting there continuously throwing money in your account. Not really, but that's the concept. You know, that's how it would be. So continuously, I'm going to go back up and I'm going to use this formula that has an E in it. Okay? So in this formula, same, ending amount, starting amount, but now we use an E to the rate, again it's a decimal, time, 3 years. Okay, so let me go back down here. I have taken the problem and I've identified everything. P is going to be 50. Rate is going to be 0.048. Time is 3. Look how I plugged it in my equation. Type that in your calculator. You get $57.74. Okay, well, compare the two. Big deal, right? Continuously earned me a penny more than monthly. Big deal. But when you make an investment, how many people, like, seriously invest $50 for 3 years? I mean, maybe as a 15-year-old, maybe. But think about your parents. If your parents have a savings account, they probably didn't put $50 in and wait 3 years to see what happened to it. So if you look at this example with a little bit more money as an investment, what if your initial investment was like $5,000? $5,000 is a reasonable amount of money for an adult to put into a savings account. At $5,000 compared over 3 years, this would be the amount monthly, this would be the amount continuously. So a little bit more of a difference. If we did this for 8 years, this difference would be even more significant. It's kind of cool. All right. Get good practice using your scientific calculator.